Hi, and welcome to the Self-Driving Car No Libraries JavaScript course. It's a course where I teach you how to make a self-driving car. Duh. And we'll do it without using any kind of libraries, so that you really understand what's going on under the hood. Now, before you say anything, yeah, it won't be a real car you drive outside, but making this kind of simulation is maybe even harder than doing it for real. Let me explain. In this course, you learn how to implement simple physics to move the car. In the beginning, we'll control the car ourselves using the keyboard to get the field that we want. I'll also teach how to create a road and how to follow the car on the road, like a drone is filming it from above. We'll then simulate some sensors on the car. These sensors work by raycasting and detect if the car is too close to the side of the road or to other cars in traffic. To implement these, we'll use a formula for segment intersection. Don't worry, I'll explain the math in a nice visual way. You'll see. We'll implement collision detection using the same segment intersection formula. It's great. It works with any orientation and can even support other shapes as well. Now, all of these are things you don't have to worry about if you're working with real hardware. The world gives you the best physics, better than any simulation. There are plenty of roads to drive on, we don't need to create them ourselves. And nowadays, cars have a bunch of sensors that tell if something is touching or around the car. Of course, if you want to build all of these yourself, then yeah, making the simulation is easier. But what are you, Elon Musk? Anyway, the second half of the course is the really interesting part. You learn how to create and visualize a neural network, an algorithm inspired by the biological neural networks in our brains. I'll briefly explain how our brains work to the best of my ability and teach you how to code something similar ourselves. Then we'll optimize the brain by trial and error. Yeah, to keep things simple, we just try randomly generating brains until we get something that works. We'll parallelize this step and use hundreds of cars at once to save time. By the way, this is something you can't do with real hardware unless you're really, really rich. And that's why car companies use simulations to train their neural networks as well. I'll also teach you a basic genetic algorithm to optimize faster. But don't expect anything too fancy. This entire system is complex, but I made it so that each component is relatively simple in and of itself. I made this course keeping in mind my high school days back in Romania, so the knowledge you get from school should be enough depending on the curriculum. We'll work with JavaScript because it's so easy to get started. You just need an editor and a browser, which you probably have already. I'll teach you many modern JavaScript techniques, so this course is perfect if you want to become a better coder as well as a machine learning expert. Now, JavaScript is not the best choice when doing artificial intelligence, but since we're not using any libraries, it doesn't really matter. If you want to learn these in a more useful language like Python, then come study at Karelia University of Applied Sciences. There I teach this same thing in Python as well, and we also study machine learning libraries and even use hardware components. But now start your engines, because the course is about to start. I'll first teach you how to implement the car driving mechanics. You learn to make a car that moves like this. It's not really that hard, you'll see. I'll refresh your memory with some basic physics and trigonometry, and you'll be able to code this in no time. It's best if you code along with me. So go ahead, open your editor, and let me steer you in the right direction. Get it? Steer? Because we're gonna make the car... No. Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now. We begin with this simple project setup. We have 3 files right here: index.html, main.js, and style CSS, and they're all empty for now. And I'm using Visual Studio Code to write this. And on the right, I have Google Chrome and you need to have the developer tools open there. It's really important. So if you plan to follow along, have a similar setup. You can use another editor if you want, but I recommend this Visual Studio Code nowadays. Let's begin with basic HTML. In the head, I'm going to write a title for this, and it's going to be self-driving car, no libraries. Really, everything here is going to be just written by us. I'm linking now the style sheet, and let me close the head, and in the body I'm going to define a canvas. We are mostly going to use this canvas in this project. Here I'm also linking the JavaScript file like this. And we are done with the HTML for the moment, at least. You refresh the page and not much happens really. It says here self-driving car, no libraries in the tab of the browser, but nothing appears in the page itself, apparently. If you open these elements, you will see that the canvas is actually there. It's just transparent. And the body actually has this orange small margin there. I want to get rid of that margin and also make this canvas visible somehow. So let's go to this style CSS next and write some styles. I will remove the margin for the body, and let's make the body have a dark gray background, overflow to hidden, and I'm gonna use text align to center for now. Overflow is important, otherwise we might get a scroll bar coming if the canvas is too big, and I don't want that. And I want everything to align to center in the middle of the page. Now my canvas should have a different colored background. Maybe we set it to light gray like this, and save, refresh. And now you can actually see the canvas without needing to inspect these elements right here. I'm gonna move back to the console. It's probably the most important thing in the developer tools. I want my canvas to stretch the full screen vertically. So I'm gonna go in main.js right here, and I'm going to get a reference to our canvas with ID my canvas we defined previously, and I'm gonna set the height of this to be the full window inner height like this, and the width is going to be just 200 pixels. It will be like a road going upwards. We'll need the space on the side to draw the neural network later. Now if I save this and refresh, you can see it appearing there exactly how we want it. Let's next pretend that we have a car and we want to draw it on the canvas. To draw on the canvas, we first need to get the drawing context. We will just use the 2D context in this whole project. So I'm going to have a reference to this canvas context right here in this CTX. And it's going to contain all the methods we need to draw the things that we need to draw in this project. And if we would have a car, we would say something like this. Let's get a car at, for example, 100x, 100y, and the car maybe has a 30 width and 50 height. All of these are in pixels. And let's draw the car using this context. But we don't have the car yet. This is the thing that we are going to need to define next, the car object. And we are going to do this first by going inside of index.html here and preparing to import a new file, car.js, like this. And now I'm going to add a new file here, car.js. In here, I'm going to say class car. So we are defining our car class, and the constructor for this class is going to have 4 different parameters. So we have here the x and the y, and a width and a height. So these are properties of the car, where we want it to be and how big should the car be. And we are going to store these as attributes inside of the object, like this, so that the car remembers where it is and how big it is. Now, remember, we also had this draw being called. So that draw was a method, and it looks something like this. It gets a context as a parameter. And in here, we begin path, and we are going to draw a car as a simple rectangle for now. The rectangle is going to start at an x and y location. So I'm going to use this dot x minus this dot width divided by 2. So the x of the car is going to be the center inside the car, and it's going to have parts in front, behind, left and right. So on the top, bottom, left and right. The y value, I subtract half the height. So here we also need to specify what is the width and height of this rectangle, like this, and ask the context to fill it, like so. And if I'm going to save this and refresh the page, you can see the car there, or at least a black rectangle for now. The car is here at 100, 100. So on computer screens, the y-axis actually goes downwards, and the 0, 0 point relative to this canvas is actually right up here. Now, this is really boring as such. I'm going to teach you next how to move the car using the keyboard arrow keys. So for now, let's just pretend that we have here some controls, like this controls is equal to new controls, and let me link a new file here in index controls.js, and also create controls.js, and we will do a similar thing as previously. So we need a class for these controls and a constructor. The controls object will have 4 different attributes. One of it will know if it's going forward, one of it for the left, one of it for the right, and one for the reverse, like this. And I set them to false initially, but these will change depending on what you press on the keyboard. So I'm next going to define a method for adding so-called keyboard listeners, so that we have a piece of code that checks whenever we press a key or release a key. So I'm going to call here add keyboard listeners, and this is going to be a method inside of the controls class, like so. The reason I put here this hashtag in front is because this is a private method. You can't access this from outside of this controls class, and you shouldn't. It's its own responsibility. So how does this add keyboard listeners look like? Well, we will add a key down event to the document and set this to be equal to this arrow function. I will explain arrow functions in just a second, but let's implement this first. So depending on the key that was pressed, if this was the arrow left key, we are going to set this left to true and break, and do the same thing for the arrow right key, like this. The arrow up key for forward, and the arrow down key for reverse. And that's it. But we also need to know when we release a key. So I'm going to actually copy this code here, like so. And this is going to be on key up. And all of these things are going to be set to false. I want to debug if all of this code that we wrote works. So I'm going to put here a console table. This. I'm going to output this entire object into the console in a table format. When I press a key and when I release a key. I save the file, refresh, and every time you press something, like now I'm pressing the up key, now I released the up key, now I'm pressing the down key, I released the down key, left and right, you can see the values in the console have changed. So this code seems to be working. Great, but why is it working? So let's look a little bit up here, and this part of the code may be a little strange to you if you're not familiar with this arrow function notation. This is actually the same thing as writing here function of event like this. So we say that on key down, this is the function that you are going to call. But if you write it like this here stops referring to the object here, to the controls object. It actually refers to this function right here. And if I undo and use this arrow function notation, this continues to refer to this object right here. So it's a difference in how these two types of functions work in JavaScript. And it's convenient to have it in this way. Now, controls are triggering, but let's move the car with them. So I'm going to go to car.js, and we are going to write here an update method. This update method is going to check if the controls say forward, let's just move the car upward. So that means y minus equals 2. Remember that y increases downwards on a computer. And if these controls are reverse, then we add 2 to y so that it goes downwards. Now this won't do anything just yet. We need to go to main.js here and start to animate. So I'm going to write here animate and define an animate function like this. And inside here, I'm going to update the car, and then I'm going to draw the car using this code we had previously, like this, and call request animation frame with animate, like so. Request animation frame calls the animate method again and again, many times per second. It gives the illusion of movement that we want. Now we can save the file, refresh the page, and when I press down, something happens. So the car updates and redraws itself, but all the past positions of the car are still there. And if I press up now, it takes a while, but then it reaches again the top part and you start seeing it again. But it leaves this black trail there. So we need to fix this. And actually, we need to fix something else as well. If I'm going to resize this console here, you will see that this canvas here doesn't stretch to fill the screen vertically anymore. This bothers me, but it's great because we can fix both of these issues by moving this piece of code from here. When you resize the canvas in this way, it means that it also becomes cleared. So if I refresh now and press the down key, the car is actually seemingly moving and it doesn't leave that trail anymore. Also, if I resize this console here, it looks proper. You might have to click on the screen here before you can press the top and down arrows. Sometimes these listeners don't activate unless you click inside the page. Okay, problem now is that this doesn't move like a car at all. We need to work on this. Cars don't move so that you press on something and then immediately stop. I'm going to go to the car constructor here and give the car a speed attribute and an acceleration value like this. And here, instead of changing the y value on forward, we are going to say that the speed will increase by the acceleration like this. And I'm going to copy this here below, but with minus. And here I will say this dot y minus equals this dot speed. I save the file, refresh the page, I press down, I press up. Whee! Okay, we need to stop the car from going too fast and implement some friction. So I'm going to go here and say max speed equals to something like 3 and a friction of, let's say, 0.05 like this. And in the update method, I'm going to move here and say if the speed is more than this max speed, this speed becomes max speed. We are capping it. The same if the speed is less than minus this max speed, but in reverse I want the car to be not as fast. I'm just gonna divide by 2 here. If it's less than this, then I'm gonna cap it to be minus max speed divided by 2. Maybe you want to have a max reverse speed or something declared on top. Feel free to do it. I think it's overkill. Also, there's no such thing as a negative speed like what we have here. The negative sign is just to indicate that the car is going backwards. Luckily, this is not a course on physics. Otherwise, I might get in trouble for this. Next thing we do is check if the speed is greater than 0. I will decrease it by the friction like this. And if the speed is less than 0, then speed increases by the friction like this. Now I save the file, refresh the page, press down, and the car is moving. I released and it slowed down a bit and then it stopped. I'm pressing now up and I release. You can see it's still moving a little bit before it stops. And I think that this feels quite okay, but at the moment the car is only going forward and backward and the left and right don't do anything. One small issue though, let me see if I can get it to happen. Okay, if you release in just the right way, you will see this. Let me zoom in a little bit more. See, the car is actually always moving. It's constantly moving, no matter if we press a key or not. Actually, if we don't press any key. And it's moving by a very, very, very small value. And that's because if the speed is not equal to 0 exactly, then this friction is going to bounce it around and eventually it's going to move it forwards by a very, very small value. So to fix this, we can actually write here if the speed has an absolute value that is less than the friction, just have it become 0 like so. And this is gonna work. No need to test anymore. Let's implement the left and right controls next. And say as before, if we press left, x gets -2. And if we press right, x gets +2. Notice how I implement a basic thing first and make it more advanced afterwards. I really want you to get the idea that everything can be improved, but that you can make a complex system even with easy components. I mean, by the end of this course, you will have a self-driving car, no matter if it moves like now, or if we implement better physics into it. Now, if I refresh and zoom out a bit, now if I press left and right, the car moves in a very, very funny, non-realistic way, but this is actually how cars move in some games, for example. So if you want to make a self-driving car for a game, then this might be enough for you. But I'm gonna teach you how to do better than this. And actually, I don't like this for one important reason. We are breaking the laws of physics. We have here the value for this maximum speed, and we can reach that maximum speed by going forward like this. But if I press right now, I'm actually going faster than the maximum speed, but diagonally, because I'm going the maximum speed vertically and a little bit to the left in this case. So this is bad for many reasons. Let me teach you how to fix it. We are gonna go up here and define an angle. Let's set it to 0. And here, instead of doing this, we are actually going to modify the angle to increase by 0.03, for example. And here we have angle minus equals 0.03. So this angle works according to the unit circle. But in our case, the value of 0 is upwards. So it's a unit circle that is rotated 90 degrees counterclockwise, if you will. But keep this image of the unit circle in mind, of the rotated unit circle in mind, because this is going to be our coordinate system for making rotations. Speaking of which, we can make a very easy rotation like this using the canvas context. First, we save the context, then we translate to the point where we want the rotation to be centered at. And now I'm going to tell the context to rotate by minus this angle. Next, I'm going to remove here this dot x and this dot y because we're already translating to that point. And one last thing we need to do is here add a call to context restore, because otherwise on each frame of the animation we are going to translate and rotate and translate and rotate and translate and rotate, and this is going to do some infinite series of translations and rotations that will look pretty funny maybe, but not what we want. So let me save this, refresh, and now when I press left, my car rotates counterclockwise, and when I press right, it rotates clockwise. So we have something there. It's not yet good. It's more like a tank that can rotate in place. Cars can't do that. But more importantly, if I rotate like this and press the down key, my car just moves downwards in this weird way. And this is not correct. And the same goes for upwards. We want the car to actually move in the direction of this angle. So I'm going to implement this based on the unit circle again. I'm going to make x go minus the sine of the angle times the speed. So unit circle has a radius of 1. This sine is between -1 and 1. So we need to scale this by the value of the speed as well. And then for y, we do the same thing but with the cosine here according to the unit circle. Now we don't need this anymore. I can save the file, refresh the page, rotate to the left, press down, and look at that. The car is moving properly. And I can actually start to feel like I'm driving a car. But backwards, it's flipped. Like, look at this. If I press backwards and right, the car turns left. That's not how it happens in real life. So we need to fix that, and also this rotating in place next. I'm going to just put here, if this speed is not 0, I'm going to calculate a flip. So I'm going to say the value of this flip is 1 or -1 depending on the speed, so that I can flip the controls backwards. And if this is the case, then here I can just multiply by the flip. If the flip is +1, then this doesn't do anything. So when the car is moving forward, when it has a positive speed, then this won't change. But when we go backwards, what essentially happens is these signs are flipped. So let me close this here and test again. Now if I press left and right, nothing happens because our speed is 0. But if I go backwards and to the right, it goes just the way I want it. And now I'm doing these I'm trying to change the direction in the car, similar to how it would happen when driving the car. Play around with it, and if there's something you don't like, change it, especially if you're good at physics. But if you're not, you can try using libraries here as well. Box2D is a really good one, I think. But I'm happy with this. There's one thing that we don't need anymore. That's the debug here in the controls. I'm just going to remove this because now I'm confident that the controls work as I want them to. I'm going to save this file, and in car, this update method starts to be quite big, and more things are going to be coming here later. So one good thing would be to group all this code here in a separate method. I'm going to cut it, and the method is going to be called move, because that's what this is doing. It's moving the car according to the controls. And the move method is going to be a private method. It has the hashtag there, and I paste the code that we had previously in here. I save this, refresh, and everything still works as previously. It's funny how you start to feel like you're controlling a car, even though it's only a rectangle. By the way, I'll show you how to make it look like a car in the final lecture when we do the fine-tuning. Meanwhile, it's actually better to keep it like this when building the system. Were you able to follow along? Then great. Please like this video if you learned something today, and share it with others so they can learn as well. And if you got stuck somewhere, comment below and I'll try to help. You can get today's code from GitHub, and the full code is actually already on my website. Check it out if you can't wait till the end of the course. See you guys.